The work session of the Annapolis City Council for Thursday, July 18th, will be called to order at 3:02 p.m. At this time, would everyone willing and able please stand for the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Mr. City Attorney, would you please present the first item on the agenda?
Yes, ma'am. The first item on the agenda, the only item on the agenda is presentation ID 118-24, straight voltage study, Truxtun Park Marina report.
Ms. Giles, turn it over to you.
Thank you. Good afternoon, Jackie Guile, Deputy City Manager for Resilience and Sustainability. Good afternoon, and thank you for attending today. We called this work session in response to the concern that we've had for several years around the stray electrical current that has been experienced in the waters of Spa Creek near the Truxtun Park boat ramp. This came to our attention by people using the waters in that area through sensations they were experiencing in the water. So that area was closed for paddling and kayaking and swimming while the city was testing and trying to determine the source of the problem and what actions we could take to remedy the problem. But before we get into the timeline of how this came to be and the actions that the city has taken in response to the issue in the waters of Spa Creek, we thought we'd talk about, what is the concern there. And the concern is around the electrical current and the dangers that it poses to people using the waters. And the harbor master has attended some training programs and conferences over the past several years, and there's been changes in the way that the boating community and the harbor masters have been dealing with electrical current and safety issues that go along with that. So we made this slide, and I would like the harbor master to address the issues around electrical shock drowning.
Good afternoon, Beth Bellis, Harbor Master for the city. So the conferences that I attend each year have had, I think for the last 3 years, a particular class put on by a nonprofit called electricshockdrowning.org. So if you'd like to learn more about it, it's a great website, but they are dedicated to educating people about how to minimize our risk. And so this slide, it's so many times there's been a drowning and people said that someone was a very strong swimmer and how did this happen? But what we know now is an autopsy would not show what that person died from. They would look like they had a drowning because it is in fact a drowning. And so this slide is just some information about that, how exactly it happens and what you should do about it. Somehow turn off the power immediately, do not enter the water, throw the victim a life ring, and call 911.
Address that. You should not, the technology, the feeling about not swimming around marinas because of electrical.
So the National Fire Protection Agency is one of the 3 organizations that Electric Shock Drowning Organization has consulted with. I couldn't name them all off the top of my head, but the standards have become that you shouldn't swim around a marina because of those dangers. And I know that's new information for a lot of people, and I feel like it just needs to get out there more so that people have the understanding that this is not particular or different. This is a body of information that's going out to everyone.
All right, so I'm going to go into the timeline next of how this information about the electrical current in the water came to our attention and what the actions the city took in response to it. So it was about July 2021 when tingling sensations or shock sensations were reported by swimmers, paddlers, kayakers in Spot Creek in the vicinity of the Truxton boat ramp. And so the city electrical inspector and the Department of Planning and Zoning and BG&E started conducting electrical testing in the waters in various areas around the boat ramp. There were intermittent readings of stray electrical current in the water. They weren't always found to be high, and they weren't always found. It was just sporadic, and it wasn't determined to be a particular time of day or a particular day or days of the week. It was just intermittent. So the area, because some of the readings were high enough to be of concern, that is, they could impair someone or cause it to be not only painful, but could cause someone to be perhaps immobilized. The area was closed to swimming and paddling while the city did additional testing and was trying to determine the source or sources of the stray electrical current. So this testing continued by the city electrical engineer and BG&E in the ground and in the water at various points on Spot Creek in that area into 2022. The city determined that there were some areas in wiring that could be addressed, so the city rewired the floating dock and the lighting in that area. They were ensuring that all their potential leaks of electrical current were resolved from the city's facilities. And then some additional testing was still found that there was still stray electrical current. BG&E was inspecting all of its feeders, its grounds, and its transformers. It found them all to be in proper working condition. It could not find that stray electrical current was connected to any one of those, but it did. BG&E went ahead and rebalanced its nearby substation, and it ended up replacing its transformer and modifying its overhead lines. After performing this work, BG&E did some additional retesting in the waters, and it found that there were some reduced readings, but the electrical current remained at times, and it was still of concern, so they knew that the issue had not completely been resolved. And all this work continued throughout 2022. So at that point, the harbor master and I discussed this, and we said, well, what we probably should do is hire an expert in tracing stray electrical currents, someone in the marine industry, and we started researching that, and we eventually located the company that is here today to speak to us, which Engineering Design Technologies. We retained them late in 2023, and they performed testing for us, and they are here to give us the results of their testing, explain the data and what that means in practical terms for us, as well as their conclusions and their recommendations for what the city can do to further reduce the stray current, or how to monitor it, what other steps we can take, and their recommendations for the area in general. So with that, I will turn this over presentation to Engineering Design Technologies for them to introduce themselves, give some background on what their company does, and then launch into their report. And I would ask that we just we've reserved plenty of time for questions and comments at the end of the presentation, which asks that we just save that for the end of their presentation.
Hello, thank you for being here today. I really am glad I can present this information to you. My name is Tom Gibb. I've been working in the field of electrical currents in the ground since the 1980s. You're having a hard time hearing me?
Sorry, Tom, if you could just get a little closer to, thank you.
Is that better?
Thank you so much, thank you.
All right, sorry about that. So I've been working in the field, literally, since the 1980s. I took all of these readings, and I reviewed the reports. I wrote the report. And this is Andrew Fuller. He's the vice president of our office, and he's a professional engineer. And this is Gwen Sullivan. She's a project manager and really good at whatever she puts her hand to. So I just want to start with a warning that we're well aware of at this point, but we're going to be talking about drowning. And we've already broached that subject, but I felt like it was important to put on the first slide. Next slide, please. We're going to have the following things. We're going to talk about the summary, introduction, the methods we used, the results we found, how we analyzed it, and our conclusions and recommendations. Next slide. Engineering Design Technologies is a multidisciplinary engineering firm with over a decade of experience investigating stray currents, and we have an office locally. We also have other offices around the country. The bottom line of our study is that with one very small, short exception, we were not able to identify or capture any stray voltages that were considered to be hazardous during this study. We want to continue to say what has already been said: swimming near docks with electrical service is never recommended, and this is according to the National Electric Code and numerous other organizations. Part of our study incorporated shutting down and starting up the power to the Harbor Master's dock. Turned off all of the circuit breakers. We turned off the main circuit breaker providing power to that sub-circuit breaker panel, and we didn't see any changes in voltage in the water. We were concurrently recording at a rate of once per second during that time that we were turning those breakers on and off. The ground current that was measured by BGE, we believe we measured the same point, and we saw 2 to 4 amps of current, as you'll find out in a minute. Those currents were fluctuating during the entire test, but they did not follow the operation of the circuit breakers. So now let's talk about the whole project. These are the 2 areas that we tested. On the upper right is the harbor. The 2 white lines on the right are the boat ramps. The L-shaped line is the docks. And down on the lower left is what we're calling the rickety bridge. Next slide, please. Here's some photographs of the dock and the rickety bridge. We also tested on the ground in 2 areas. This is one place we tested. I basically walked over this entire area while having my meter connected to the electrical grounds at the panel. And I took measurements of the soil all throughout this area in an attempt to find any kind of voltage gradients that would point to a source. Next slide, please. We also set up a data logger recording 1 time per second in this location underneath the trees. We picked that location because it was away from where people normally travel, and we had to stretch out a wire for 5 days, and we didn't want anybody disturbing it or tripping on it. And this is the location where the grounds were tested. It's a circuit breaker panel that's on a pole next to the dock. There is no electrical on the top of the pole. The electricity to that circuit breaker comes underground about 200 and some feet away, from about 200 and some feet away. As you know, there have been reports of electrical tingling, and electric shock drowning is a serious public health concern. That was very well covered. Thank you. Just so you know where stray voltages can come from. They can come from shipboard power. If a boat is wired incorrectly, it can cause electrical currents to flow from the hull. Shore power to vessels. Again, if there's something wrong with the wiring, it can cause electricity to flow from the ship to the shore and can, again, cause electric shock drowning. Electrical power distribution systems and pumps, etc. As you know, there's a substation not terribly far away. There's also a power plant that's further north, and there are electrical connections between them. As long as those electrical connections are maintained properly, there will not be any significant current in the soil. But if something goes wrong and power is sent through the earth, it'll create quite a problem everywhere in between those two locations. Corrosion control systems. Throughout the whole United States, there are underground pipelines and fuel tanks, all of which are required by law, if they carry hazardous materials, to have corrosion control systems on them. These control systems intentionally force electricity through the soil. Generally, they don't cause a problem. The industries that use them are very careful about that because those currents can cause corrosion to other people's pipes and tanks. So those are very carefully monitored. By federal law, the pipelines have to be constantly monitored, so people are walking along them, checking the systems on a regular basis. State law requires every fueling system, every gas station that has these systems to be tested every year. Doesn't mean they don't break and things don't go wrong, but at least we try to stay ahead of the game and correct them. Finally, solar activity. I don't know if you all are aware, but we're really in a high activity time right now. We've had Aurora Borealis visible all the way as far south as Florida. That's amazingly unusual. That activity can be picked up on any piece of metal in the ground and cause ground currents. There's absolutely nothing we can do about that. We just need to be aware that it's a possibility. I say at the bottom here, note that conditions causing stray voltages could change at any time. So let's talk about possible power distribution problem. Say some car runs off the road, too far ahead. Say a car runs off the road and hits a telephone pole. Well, you immediately have two possibilities. One is that a high power line will touch the ground. That will create voltages flowing in the ground. And I'm sure you've all seen BGE's warnings about that. Stay in your car. If you have to get out of the car, then take very small steps. Don't take big steps and move away from the wire as quickly as possible and so forth. That's one problem. Another problem is that the wire could become broken from one pole to another. While it doesn't always hit the ground, it can hit other things. It can hit the guy wires going down to the ground from the pole. That'll induce voltages in the ground. It could also cause an imbalance in the entire system, which can cause voltages to pass through the ground. Next slide, please. Let's talk about tingling sensations. We already touched on that, or you already touched on that very well. But let's talk a little bit about what the different effects of different voltages are. So direct currents, which are the currents that are used to protect the pipelines and fuel tanks that I was talking about earlier, are not normally detected by humans, except when they start and stop. Alternating currents, on the other hand, effectively start and stop repeatedly, and as a result, are much more easily felt. Additional research has shown that currents as low as 1/1000th of an ampere can be felt. Since all the measurements in the study are reported in terms of thousandths of a volt, we must consider the resistance of the human body to the flow of electricity to find the voltage corresponding to milliamps. Scientists often use a conservative value of 300 ohms for the electrical resistance of a human in water. Now, when I say conservative, they initially tested and came up with a number of 400 ohms, but to be extra cautious, they are suggesting that we use 300 ohms in our calculations. For that reason, a stray voltage of 300,000ths of a volt will be perceptible. Now, if you were to see that 300,000ths of a volt or millivolts written in terms of volts, that would be 0.3 volts. Next slide. As already was stated, there were drownings of healthy and capable swimmers, and their rescuers were reported around docks and boats. Eventually, investigations revealed the presence of electrical currents in waters where the drownings occurred. This only happened because people were convinced that there was no reason for this person to have drowned, and yet that's what the findings were, that they had drowned. And they asked for further investigations, and that's when when the research was done and they found the voltages. Additional investigations revealed that the electrical currents did not always cause electrocutions. As you said, people were drowning. There was no sign of shock, no burn marks, no tissue damage, and it was found that the current can cause muscle contractions so that people can't swim. It can, at higher amounts, can prevent breathing, causing the muscles in the chest to constrict. And it can stop the regular heartbeat, which we all know as VFib, where the heart beats erratically. And finally, at high enough currents, it can cause tissue damage, which would obviously show up in an autopsy, and they would know that there was electrical current. But usually people die at the lower voltages, or often people die at lower voltages. Next slide, please. All right, how we ran these tests, methods we used. We used two different kinds of meters. One, I've alluded to already, data logger. We set it up to measure once this.
Excuse me. That's a TV station over the road.
Crosstalk, okay. I thought maybe God was here or something. So we did data logging in two different ways. We did it at the dock. We did it at the Rickety Bridge. And we did it at the hillside in the Doyle, in the dirt. And we also put a data logger on a little rubber raft and paddled it out in the water. And so those are the two different ways, stationary and in motion. I also used a digital multimeter to take readings on the soil, as I showed in the original section where we were showing maps of the different areas. We used calibrated, industry standard, portable reference electrodes in contact with the soil and water. These electrodes are intentionally designed to be extremely stable. They give very consistent readings over a long period of time. They are sensitive to some things like big changes in temperature, but I took precautions to prevent that. That's part of the reason why I went under the trees with the stationary ones. I also covered them with leaves so they'd be protected from sun. We just lost our, oh, it's back. And somebody asked earlier during an early presentation whether the meters provide RMS or peak readings. They provide RMS readings. That stands for root mean squared. It's a way of measuring the area under the curve of the voltage. Next slide, please. So the long-term readings were usually 5 or 6 days long. We made an effort to record over a weekend so that human-influenced voltages would be apparent. In my experience, I found that voltages change with the time of day and the day of the week when they're caused by houses or by people in houses. They peak in the morning, at lunchtime, at the end of the workday, and in the evening, and they peak all day on Saturday and Sunday. As I said already, we took those readings on land to the south of the dock, in the water adjacent to the dock, and I can hardly read that.
In water.
Oh, in the water, to compare with what we saw on the land and in the water adjacent to the rickety bridge. That's, as far as the instantaneous readings, I did them in 2 locations between the grounding system for the dock's circuit breaker panel and an earth probe. That's in the area that I walked around. And also, I measured electrical current flowing through the dock's circuit breaker panel grounds. Now, that panel and most similar panels are equipped with metal rods that are driven into the ground, 1 or 2. This particular one has 2. They're connected by a heavy solid wire usually to the panel's electrical system. And it's very unusual to see any current on those wires, but we did measure some, as you'll see. Next slide. I don't know if you could see the little red L shape in the middle of the dock there, right at the corner. We had 3 half cells at the 3 points of the L shape plus another one. Next slide. We took the boat out. We left from the boat ramp. We took the little paddle boat out and we took readings across the inlet there, all the way back around to the dock, underneath the dock and around the dock.
And if I may, I'm going to back up a slide.
Sure.
The testing arrangement for the rickety bridge is shown inside of that second map at the top right. So it's similar to what was done at the dock, where you have.
Except for just 2 cells instead of 4.
Correct. Just to point that out.
Thank you. So the white dots are where we took the boat out for paddle, and the red dots are where we towed the boat around the dock, trying to see if there was anything specifically coming from the dock. Next slide. These are the results that we had. Almost all of the readings, all the voltages which we recorded were below the sensible threshold, except for 7 seconds at the rickety bridge, both on the water and on the land. Stray voltages which were observed on land and grounding currents were not indicative of electrical leakage from the Harbor Master's dock's power system, and I'll explain why. The current on the grounding system of the circuit breaker panel near the dock were present when all power to the dock's circuit breaker panel was turned off. There is a main circuit breaker or a disconnect that's a couple of 100 feet away up by a pavilion. That was turned off, and those currents continued to show up at the grounds on the sub-panel at the dock. There was no significant change in the pattern that I observed. I observed them going slowly up and down, up and down, up and down over a period of about 20 minutes. I also observed them at other times when I was there doing other tests. So there was a consistent flow of current. It didn't matter if the panel was turned on or off or the breakers were on or off. Next slide, please. I'm sorry this is so small. I didn't realize the screens were going to be this tiny, but you can get copies of this. But this shows the location, the amount of the voltages measured, the peak that we saw on the rickety bridge was for an extremely short period of time, over 7 seconds. We saw a couple of spikes. And we believe that there was a storm in the area at the time. The Navy has a record of storms in the area, and they did record a storm at that time. Same thing with the AC and DC readings in the other locations. They were all below that 300 millivolt criteria that we mentioned earlier. We did measure a 179 hertz signal on the ground. That is really close to 180 hertz, which is the third harmonic of 60 hertz. The reason why that's important is that it's generated pretty commonly by computer power supplies and some motor control systems. The table on the right is from a study done by a medical facility, and it talks about that they actually measured milliamps. I converted them to millivolts in that second column there. And they found that 1 milliamp was barely perceptible. 16 milliamps was enough to cause an adult male to feel it very painfully, but still be able to let go of whatever they were getting shocked from. 20 milliamps shuts down breathing, and 100 milliamps will stop the heart beating normally. We'll talk some more about that later if you have more questions. Any questions about it? Go ahead. And this is our analysis of what we found. We didn't see any changes in voltages recorded in the water during the time we were turning the breakers on and off at the breaker panel next to the Harbor Master's dock. We do not believe that the Harbor Master's dock has anything to do with any of the voltages. Now, just so you're clear, while I was recording 1 reading per second for almost 6 days, I did not see any evidence in the water of the breakers being turned on and off. There was no concurrent changes. Over the course of 10 days of data logging and observation of instantaneous measurements, no significant voltages were detected in the water except for the spikes by the rickety bridge, and they were only over a course of a few seconds. Measurements on land showed stray voltages which appear to be associated with human-controlled electrical equipment. The voltages did not appear to present any hazards in the water. We didn't see any sign of them. The only place we saw them was on the land. We didn't see any sign of the same pattern in the water. There was no correlation observed between the anomalous current measurements in the electric grounding system and the voltages in the water, which I've already said once before, at least. Conclusions. No hazardous amounts of stray voltages were detected during the study, except for that 2-second period. The electrical ground system currents do not originate from the Harbor Master's dock's power system because the power system was off and they didn't change. Sources of hazardous voltages and current can appear at any time due to many reasons, as I already talked about, but that needs repeating. We cannot ever say that someplace is entirely safe to swim. Obviously, some areas are going to be a lot safer than others, like in the middle of the Pacific Ocean. But there's no guarantees in life. I hate to put it that way, but you can't guarantee that someplace is safe. Next slide. Following our recommendations, continue to put the signage up that you have there now, which is actually more conservative than what the National Electric Code says should be up around any dock with electric power on it. Of course, respond immediately to any reports of sensations of electricity by shutting off electrical power and evacuating swimmers. Maintain all electrical equipment associated with the facility in compliance with the National Electric Code. I know from my years of experience that electrical systems degrade over time. They degrade because of changes in temperature. They degrade because of storms. They degrade because of ultraviolet light. They degrade because of accidents. They degrade because of corrosion. Did I mention that before? All these things can cause problems down the line. Here's something, a little piece of information that most people don't realize, but you know about tides here. Are you aware that the earth moves as well as the water? Probably not. You probably never noticed it because it's so slight, but it actually happens. And it can cause changes in buried conduit, pipes, etc. And anybody in the industry that has to do with moving fuel from one place to another has seen problems of that type. I did an investigation a few years ago where a pipe had broken off between a tank and the fill pipe, and actually 2 different pipes where that happened. So, you know, when the old song that says that the earth moves under our feet, well, that's true. We need to continue to investigate any possible sources of tingling sensations. I would suggest by interviewing the people who reported them. I would suggest that might give us some additional information. Might not, but it might. Next slide. Open for questions now. If you didn't understand, please feel free. If you want additional information, we brought additional supporting documents.
And could I just ask before I take questions, Beth, how many official reports of tingling did we get?
To my knowledge, there was only one, but I think other city employees possibly could have received the complaints and I didn't. I only know of one.
Okay, thank you. Alderman Tierney had the first question.
Yeah, I was just curious, on your data points or what you call them, you mentioned the rickety bridge, and I'm just curious on why, and number 2, if you were to increase the study area to that point, why did you look at the Spa Creek Marina? Beth's aware of the Spa Creek Marina at the foot of Spa Drive. That's, you know.
I did not look at the Spa Creek Marina. That wasn't part of our study area.
So to your question, initially we looked around the Truxton Park boat ramp and the adjoining areas where the data points were shown with the little red dots and the white dots.
Yeah.
Because that's where the complaints were. And then we asked, so the first round of testing was done in March, but then we asked EDT to do additional testing in June because it was peak boating season, and we know that the piers and marinas were being used a lot more. The electrical systems and the electrical systems on the piers and on the boats were being used more in June than they were in March, so we asked EDT to do more testing to see if there would be any difference. We wanted to make sure we were capturing all of the data. So they did that additional testing. And then it came to my attention that near the rickety bridge behind the Truxton Park swimming pool at the end of that road, that's where the bridge spans Spa Creek at that point that we call the rickety bridge, where the bridge is there, that area is being considered as a potential kayak paddleboard launching area for the future. So we asked EDT to do additional testing there, since we're considering using that as another launch area.
I was wondering, what
So,
the heck is that, the
yeah.
rickety bridge?
So,
I'm concerned
since the city-
because I have
yes.
residents on the other side, and
So since the city's considering using that area, we thought we should test it as well and see what the readings were in that area.
okay.
But if you'd like, I can answer the second part of that question. Alderwoman Tierney, Mr. Fuller, if you could go back to a slide that has the overheads of where your testing occurred, I will show you where Spa Cove Marina is.
Sorry, Spa Cove,
It
yeah.
probably is within your testing area. So,
The red dots are, I think.
yeah, the one with the red dots is probably good. Yeah, so if you were looking at those 3 finger piers, sort of bottom middle, just to the right, that's visible with sailboats, that is Spa Cove Marina. So you have testing right close to that, so I would leave it to the experts to tell you if that would include that area, if it's close enough.
Thank you. That's reassuring. Yeah, and then could I just ask, it's kind of a nerdy question, but when you had that graph of different increments of electrical and what would happen to the human body, it was at the end, you know, you had the gradations, you know, it went from 1 to 16 to, yeah, that. I was just curious, just for my own knowledge, but is that on a logarithmic scale when you go from 1 to 16 to 20 to 100? It's just, I can't explain that. I don't.
Sorry, I don't recall that they talked about it. The area at the bottom explains where this study came from.
Oh, okay, yeah.
And there may be more information there, but I do not recall that they said
Yeah.
why they picked that particular scale. We would have liked it to have another number in there for ESD, but they didn't do
Yeah.
that test.
Yeah, I was just trying to find some logic with those gradations, you know? You go from 1 to 16 to 20 to 100, what happens at, you know, 75? It might be a logarithm thing, I don't know.
So just in general, I mean, the scale itself is not logarithmic, right? So there's the
Okay.
difference between 16 and 20.
Yeah,
There's not, I mean, that's a linear scale, not a logarithmic scale between
Okay,
20
I'm
and
just-
100, right?
right.
The human body in general, often our perceptions are logarithmic, like our sound is measured logarithmically, you know, lumen, the way our eyes work is logarithmic. I don't know if our perceptions and therefore our response is logarithmic,
Yeah.
but the scale itself is not.
Okay, thank you,
Yeah.
Vicky, fellow.
Can we go back to the question that Alderwoman Tierney asked about Spot Cove Marina? We went to that slide, but we didn't answer the question, whether that testing point was close enough to measure Spot Cove Marina
Yeah, thanks.
with the red dots and the white dots. Okay, so we have those two white dots close to the sailboats. Were those points, data points, measuring points close enough to measure that marina where the sailboats are? Any of you?
We have a slide that shows, or actually we have two slides that show our measurements in those areas. This particular one is alternating.
Closer to the microphone.
I'm sorry, this particular slide is the readings where we took the boat out across the water and around to the dock. 1 and 2 are by Spa Cove. 3 and 4 are across the water from Spa Cove, and then we come closer and closer to the dock, and we finally end up going around the dock from like 13 to 21. But pay attention to the scale on the left. That is volts, not millivolts, that's volts. So that bottom number is 10 millivolts, and the uppermost reading is 50 millivolts. So they're all below the 300 that somebody would feel, but the 1 and 2 are right around 10 millivolts, which is pretty close to the lowest that we read.
Thank you.
Alderman Savage?
Thank you, Mr. Mayor, and thank you for this report and analysis. A number of questions. First of all, you mentioned in one of the slides that the readings were reduced after BGE made some improvements. How much were the readings reduced after their work?
I don't know for sure because I don't know exactly where BGE took the readings, but I suspect they were at the same location, and they were 4 to 6 when BGE took the readings, and I was reading 2 to 4. If it is in the same direction, same location, that's a pretty significant change, but we still don't know where those currents are coming from. Because if you turn all the power off, we know it's not coming from the electrical system there. They may just be currents in the soil for whatever reason, but we don't know the reason, and we don't know why they changed when BGE did the work. And we don't know if it changed concurrently with them doing the work because we don't have any readings around the time that they did the work. We don't even know when they did the work. So we have not interviewed BGE.
What was explained to me, Alderman Savage, was that they made some, in addition to some of the transformer overhead lines and some other adjustments they made, they also, and they replaced their transformer to see if that would help, but they made some adjustments to one of their substations. And they thought that maybe that would help because they said there's power that when it's not used, it travels back through the ground to the substation. So the adjustments they were making was in, power being used. So they were thinking, well, if all the power is not being used, we'll just adjust it a little bit. And so we can try not to have as much unused power traveling back to the substation. That's my understanding of the way they explained it to me. So they thought that the adjustments that they made could have helped with that. But that's they couldn't pinpoint it to that adjustment.
Are the cables going through the park, are those electric or communication go under the water through the park? Are there a couple of markers there?
If you're talking about the ones in Spa Creek that have the cable crossing sign,
Yeah.
is my understanding that those have to do with like cable television. That's what I've been told.
Okay.
But I don't know for sure. But I would like to just finally answer just the last piece of Alderwoman Tierney's question. For those of you that are not aware, there was also a problem at Spa Cove Apartments. I assume that's why you're asking the question. I don't know the specifics, but I do know that Spa Cove also made repairs. So it's quite likely if we looked at Mr. Pratt's original data that contributed. I couldn't say.
Okay. As far as the rickety bridge, you mentioned in one of the slides, I think that the large spike we saw, which looked to be at unsafe levels, was related to a lightning strike.
We don't know that. We don't know if the storm was a lightning storm or not. I have seen historical animated maps that show a lightning storm going through the area. But I do have concrete data from the Naval Academy saying that there was a storm. There was water accumulation during that period of time at the Naval Academy. But I don't know for sure that it was a lightning storm. I don't have any solid records of that. I just as one video, not a video, an animated storm tracking. There are civilians that have set up a lightning tracking system all across the world. They are all volunteers. They set up radio receivers that are connected together to servers, and they use the time of flight of the electromagnetic pulses caused by lightning strikes to localize the storms, and they create animations of those storms. And but it's not official data. It's, like I said, it's a bunch of volunteers doing it. Could be highly accurate. It might not be too. I just don't know. I would like to address something that you said, if I may. Apparently BGE told Beth that unused electricity goes through the soil. That is incorrect. It does not go through the soil. It's not supposed to go through the soil. What can happen and has happened in the past is if a neutral return line between a substation and a power plant becomes damaged for some reason, BGE has in the past used ground rods to return that power to the substation. When they do that, it has one positive effect and one negative effect. The positive effect is the substation can remain in use, which means people still have their lights on. It takes a while to replace those big cables. A, to find the problem, B, to get the crew out there to either dig it up or hang another cable. During that period of time, while the current is going through the ground, it can cause a lot of problems. It can corrode water pipes. It can corrode sewer pipes. It can cause theoretical sensations, probably to some animal with a lot of space between their legs, like a cow or a deer or something like that. Most humans probably would never notice it, but that does happen. It's not normal. In fact, in the United States, from what I've read over the years, return through the soil is not practiced by any power company as a regular way of doing it. Unused power is simply not generated. They'll slow down their generators if people aren't using a lot of power. They'll cut back on the number of generators operating, but it definitely does not go through the earth.
Thank you for the clarification. So, and it sounds like I was going to ask about, because in that particular area of the boat ramp, there are really only 3 marinas, docks, right? There's the city dock, Spa Cove Apartments, and then across the creek, there's, what is it, Spa Creek Landing or something like that, it's called, I think. But I was going to ask, well, I guess I should have asked that. Did the electrical inspector Pratt, look at those properties, inspect those properties, and do a similar test as far as, or should he? Because well, I'll just stop there for the moment.
I'll answer part of that. I don't know exactly where Inspector Pratt took his readings, but I would defer to the experts as to how far those marinas could contribute. I couldn't answer that. So maybe there's a particular yardage that's a standard.
The only thing I've seen in my reading is within 50 feet. Whether that's adequate or not, I believe would depend on the amount of current. There are 2 things that affect the amount that somebody will feel. One is the distance from the source, and the other is, of course, maybe 3 things if you count the amount of current. The other is the salinity of the water. So that changes throughout the year, as you know, as there's rainfall on the ground. The water in the Chesapeake Bay gets less and less salty, and when we have a drought season, it gets more and more salty. So that will affect the amount of conductivity of the water, and it will affect the amount of possible shocking that people will experience.
Okay.
To follow up on your question, the summary that I received from BG&E on the work that they did perform included a statement that BG&E took voltage readings at nearby docks. It doesn't say how near the docks were, it just says nearby docks. And BG&E found similar readings to those they found at the Truxton dock area. So they were no different.
Interesting. All right. Well, I mean, cutting to the chase, it sounds like, if I understood you correctly, one of your findings were that there are no hazardous amounts of stray currents detected during the study. I mean, if that's the case, are we able to move forward? I used to live in Spa Cove Apartments for about 4 or 5 years. Go to the park frequently. I know it's very popular. I'd like to be able to, personally, I'd like to be able to reopen that to some degree to the public for a small craft launch, maybe even wading in the water, something along those lines. So are we able to do that at this point if there are no hazardous currents?
So currently, between the work that the city did, BG&E did, and perhaps Spa Cove Marina did, we seem to have reduced the amount of stray current in the water. Now, as EDT has told you today, there can always be some amount of stray current. And it's intermittent, we don't know. It can come from a very remote location. The report states that it's man-made in nature. It can come from remote location We don't know. So we have to continue to post signs that there is stray electrical current in the area. However, we have not detected at this time hazardous stray current. So we feel confident that we can reopen the area to paddling and kayaking. It's probably never a good idea to swim around docks, as Beth has testified here today. You know, there's much more knowledge about electrical current around electrified docks, more so than there used to be. This is nothing new. We just know more about it now. We know more about why people have experienced shock, and there's, you know, people drowning from electric shock now. We didn't know before, now we do. So it's probably not a good idea to swim around electrified docks, and there's boat traffic in the area. So again, probably not a great idea to swim in the area. But we can reopen the area to paddlers and kayakers again. Also, really it wasn't a swimming area before. People started swimming there when the pool closed down at Truxton. The pool's now open. We've got a pool opening at, you know, at Harbor, at other places in the city now too. So we don't really need that area for swimming.
Yeah, well, good to hear that we can. It sounds like we may at least be able to open up to small craft, but I'm still a little concerned about the signage, because I know that's one of the complaints.
Well, the signing has to change, because right now the signing says no paddling, no kayaking.
Okay.
Yeah.
So, well, I guess just my point is, I think we should be very careful with the wording. I think people should be aware, but frankly, it sounds like you've detected this stray current all over that area of Spa Creek, and it could happen anywhere. So we could put the sign, we should probably put the sign up all over the city, all over Spa Creek on each of the street end parks. But I say that not because I want to do that. I don't want to do that. It just doesn't make sense. I think that's going too far. If we're having a report that it's not hazardous, let's just figure out a way to, maybe if we feel like we have to make people aware. But again, why do we have to make people aware here and not on the rest of Spa Creek?
I'll say something and then I'll let you can finish. I think Mr. Gibbs said our language was more conservative than it needs to be. So I'm going to ask.
I'm sorry, I didn't say that it needs to be.
Okay.
It's more conservative than the National Electric Code.
Okay.
It's more conservative than the National Electric Code verbiage. It doesn't, I did not mean to imply that it needs to be. I approve of the verbiage that you guys are using because it's more conservative. That's my personal opinion, unofficial.
But what about my question, though? It sounds like we would need to notify the entirety of Spa Creek at each of the public water areas if this is an issue on that creek. So why do we have to do it at this one park as opposed to the entire?
I personally can't answer that question officially as an employee of EDT. If it was up to me, I'm a very conservative person. I would have those signs anywhere there's power lines on a dock. I don't like seeing people get hurt, and too many people get hurt, too many people die.
Okay, great.
Yeah.
Okay, Gwen Sullivan here, hi. I think I just wanted to comment that I believe the national code does not recommend swimming in their specific language.
Right. I'll read now
Go
from
ahead.
our report. In the recommendations, we speak to the National Electric Code requirements. Article 555.10 indicates permanent safety signage and specifically says, warning, potential shock hazard electrical currents may be present in the water. That's out of the electric code.
Under what scenario?
This is near a docking facility, boatyard, or marina I believe the electric.
It's NFPA 70, which is the electric code, section 555.10.
How near though? 'Cause I'm asking because we have a lot of marinas in Annapolis, a lot of docks. We have a lot of private docks that are powered too. So I'm trying to figure out, do we have to do this on the whole city? I'm trying to narrow this down to figure out what makes sense for us.
Correct.
So what, is there a distance on that? How far from a dock?
Or how large of an area? Is it
lot of
every
us-
pier, or does it have to be a
Yeah.
boatyard or marina? And how many slips does that constitute? Three?
The local authority having
3 hours.
jurisdiction will be your guide in that, and that is your local electrical inspector, who has to sign off on every electrical installation. Unfortunately, this is me speaking now, not EDT. Unfortunately, a lot of the codes do not get applied to things that were built before the code was written. You understand what I'm saying? So if it was built and signed off 10 years ago before this code was written, you don't, as far as I know, you don't legally have to add a sign. But if the dock is built after this code was approved, accepted by the county, then it does have to have the sign.
Is this a code that the city has adopted? Is this part of the international code?
Every jurisdiction is different. Some jurisdictions have the right to accept and reject codes. Others have to go by the state. So I don't know what the specifics are here in Annapolis.
Okay, I'll just, my final remarks is that I do want people to be safe, but I also want to make sure people aren't scared of the water. We're really trying to do a lot to clean up our water, improve water access, and if we start putting signs up all over, we've already heard it, I've already heard it, people are going to be nervous. Why is there this sign? What do you mean I can't swim? What's going on with our creeks? And if this is all over the place, we're going to be getting those signs, those comments all the time. So I'm trying to think out what actually makes sense on the ground as opposed to what the recommendations might come from up high.
Again, speaking personally, I'm sure we all remember what happened when the federal government wanted us to all have seatbelts. I'm pretty sure we all are old enough to remember the outcry for losing our freedoms, and then less and less people were dying in car crashes.
Yeah, but how many people have we lost to drowning because of electrical currents in Annapolis?
I can't answer for Annapolis, but I saw 176 on a report, and another 73 almost.
Is that nationally correct?
So I think we will be putting out some standard warnings, swim at your own, paddle at your own risk stuff. We'll have to work that out. But this is great information, and we're really happy that you did this intense study here. I think we have some other questions. Alderman Schandelmeyer.
Yeah, it might be a
Still can't hear you.
hardware muting because Zoom's not.
Oh, no. I have a quick question.
Go to Alderman Tierney while you're unfreezing, Alderman Schandelmeyer. Can you try now, Alderman Schandelmeyer?
He said that's okay.
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 Thank you, Alderman Tierney.
Just for clarity, were you charged with finding the source of the problem, or were you charged with evaluating how hazardous the situation was? Because it sounds like we haven't found a source, but was that, part of your scope?
That was definitely the intent, but because we did not detect any consistent voltages that
Okay.
pointed towards a source, we weren't able to do that.
Okay. That's okay.
And, as we
That's
saw
your-
at the
that was your
Rickety
approach.
Bridge, we saw those 2 spikes over a 7-second period that happened to coincide with a storm in the area. That's the only thing that we could attribute it to. We actually brought graphs showing what we detected on everything, and you can plainly see that Rickety Bridge was pretty darn boring, except for those two peaks.
Okay. Because the reason I ask is it relates to what Alderman Savage was saying, is that the situation, could be somewhere else if we didn't find something substantially that caused it. Do you know what I'm saying? But we don't want to alarm the public. I don't even know how to share this to anyone, I don't want to. So, thank you.
I think the takeaway from this is that, we had experienced some tingling sensations and shock sensations there in the past. The city has taken some action to reduce stray voltage on our own through replacement of some wiring, and BG&E also took action to adjust their substation. They replaced a transformer and some overhead wiring. Spokova Park Marina also made some repairs. This seems to have reduced somewhat the stray voltage and the current in the water. And then the retesting of the area we did with our marine electrical contractor found no current at hazardous levels at this time. So at this time, we now find it safe to re-enter the water for paddling and kayaking in this area.
So why are we putting signs that say no kayaking? I thought.
Well, we can remove those now.
Okay.
We had,
Or it could be paddle at your own risk or something.
it could be a paddle at your own risk. We did, this is an area where we have found
No
electrical
pontoon
current.
boats.
And to Alderman Savage's question, we have not had reports in anywhere else in the city of shock sensations or tingling, but we have in this area. So this could be, an area where we do post signs because of that, as a precaution.
Alderman Savage?
Just real quick, I know I was asking some pointed, policy questions, but I want to make it clear, I'm very grateful that staff and the consultant have looked at this. We've been getting a lot of questions about why it's not open yet. It's been a number of years, as you've seen, and so I do appreciate that. Because at one point, I think we were frustrated because the answer is, well, we don't know, And so thank you for being willing to take the next steps and investigate. It sounds like we've done our due diligence and have made improvements, both us and the state, that will hopefully help reduce the occurrence of any other stray occurrence. So anyway, I feel like we have good data at this point. And thank you.
I mean, if it's helpful, I think I would also add that it took us more time than we would have wished to figure out exactly which experts were the ones to do this job. And so it wasn't immediately apparent, and it took us a long time to realize that an electrical inspector is not by any means what these people's expertise is. So.
Thank you. Alderman Finlayson?
Mr. Mayor, Alderman Schneidermeyer, I don't know whether he's live now. He emailed or sent a text with his questions. Would you like for me to read your questions, or are you live now?
Check.
Yay.
Yep.
Okay.
Oh, awesome. Thank you, Alderman Finlayson, for calling that out. So look, I have a couple questions here. So we said we can reopen this. It's been closed since 2021. People are very angry, and when can we reopen this?
Now,
Right now.
we could open
So
now.
when I respond to a constituent saying, hey, can we reopen this? I can say yes, and they can go in, no issues, correct?
Does the harbor master have any issues?
I think I will always defer to our Office of Law and our risk manager for the bottom line answer to that. But it appears to me that we're in a consensus that kayaking and paddleboarding may resume immediately.
Great, thank you. I would ask our team to get the updated signage on that
Yep.
ASAP.
We can bag
so-
them. We can bag them for right now, Alderman Schneidermeyer, before we can get Public Works to remove the signs.
Sounds like Gavin has to go kayaking.
I'm going over there about today after this.
Okay. So I guess some other follow-up questions that I have then is, did all these issues start happening when BG&E's transformer broke?
We have no evidence of that.
No evidence of that. Okay.
Correct.
Because that was how I remember the narrative around this. I don't know if that was coming from us or coming from just the general public.
I think that's from the general public.
Okay. Was a possible source of this current, since we couldn't really detect it from our dock, was it coming from an on-land source? If I understood your presentation correctly, you were saying in the soil around the area there was a noticeable amount of stray electrical current.
What we saw in the soil was a pattern consistent with human use of electrical power, with peaks that occurred in the mornings. Can you put that slide up or no?
So
That's the slide. Right?
Yeah.
I don't know if you can see that.
I don't know if you can see that or not, but you can see regular peaks there, 1, 2, 3, 4. The fifth day, there were no peaks. They are sort of kind of random, but they're also very closely related to each other in that they all happened in the morning, and they lasted for various amounts of time. The first one on the left is, I believe, Thursday morning. Is that correct, Gwen?
Yeah.
Thursday morning, and then Friday morning. Saturday, there was just a couple of little blips for a few seconds, and then Sunday morning, again, there was several hours. We can only guess at what those sources are. The underlying lines, the jagged lines, are absolutely typical of what I've seen in the past from electricity flowing through the soil from the power systems of BGE. Why they're there, really, there's like 100 different reasons why they could be there. We don't know why they're there. But again, this was only seen on the land. It was not seen in the water. We took readings, for 6 days in the water. We didn't see any sign of this. This was 5 days on the land.
Thank you. And again, I apologize if I misunderstood your presentation. You mentioned 50 feet as kind of the magic number for how far some of these stray currents can travel. Did I understand that correctly?
Hang on. Oh, there we go. That's a number that I picked up in my reading. I can't tell you exactly where I read it, but it was in one of the many documents that I read. They recommended staying 50 feet away from docks. Whether that has any scientific basis or not, I don't know. It could have just been something somebody pulled out of the air and wrote down. But that's the only thing I ever saw.
So could a solution or a response to making these areas safer be no electrical current is permitted within 50 feet of a public boat launch? Or would that just be coming up with something based on pseudoscience with no real basis in reality?
Yes, I agree with the second statement. I don't know that there's any basis in reality. I would have to do further research on it before I could answer that question.
But I think,
Okay.
I think it would be worth emphasizing, though, that part of the testing here did include interrupting all current to the Harbor Master dock, and it did not have any impact on the voltages seen within the water at the same time.
Well, where I was thinking is that could have come from potentially some of the other docks or other private docks if they had electrical systems going into it. So that was my thought process. But if that 50 feet number is based on nothing, is there a number with your expertise that would be based on reality? Or is it all just so depends on the situation that we can't come up with a specific number with any basis?
That's correct. I tried to allude to that a little bit when I talked about the salinity of the water. It's going to change throughout the year. That's going to affect how likely somebody's going to feel a shock. The amount of current is going to affect it. So there's just too many variables to come up with a fixed number of feet.
Thank you.
Any other questions? Well, I just want the public to know, how seriously we take public safety. This is based on one official complaint of tingling. It's taken us quite a few years, but we have a nationally recognized company here that has identified that the source is not city property, and we still don't see any threat in the amount of current in the water. So we will be moving forward with reopening with warning signs, of course, with the right risk management language, I'm sure. And it'll be great to get people back onto Spa Creek and activating that part of the city. So your study has been very, very helpful for us, and we truly appreciate your service. Thank you.
Thank you for the opportunity.
Thank you so much.
All right, so this is the only thing on the agenda. We're good to go if you guys are good to go. All right, I'm going to adjourn the meeting. Anything else for good order? Shannemeyer? Nope. Okay, meeting adjourned. Thank